Hello guys. In today's video, we are going to dive into the basics of merge sort. Before proceeding to learn merge sort algorithm, you should know the crux of DAC and how to make recurrence relations in DAC. Basically, recurrence relations are made to calculate the approximate time taken by the program. DAC and recursion are related to each other up to some extent. In both, stack is used and functions are called multiple time again and again to the stack. Here DAC means, first we divide our problem into subproblems, then we solve each subproblem recursively, and at last, we combine the solution of each subproblem to get our output. Suppose we have a large input n. To solve this large input, we will divide this problem into subproblems. While dividing the problem, there will be some time taken by the program. So let's suppose the time taken to divide the problem into subproblems as d of n. And then, we will combine the solution of each recursively solved problem. And there will be also some time taken by the program to combine the solution of each recursively solved subproblems. We will suppose that time taken as c of n. Now, let's try to make a recurrence relation for this problem. Let's suppose the time taken to execute the function t as a n argument in it equals to t of n. Now, time taken by the function t as a n by 2 argument in it takes time equal to t of n by 2. Here, every time the problem will be divided into two subproblems for each input, and every time the value of input will be halved. Since each time the input is halved and the problem is divided into two equal parts, the recurrence relation would come out to be the twice of function t of input n divided by 2 plus the time taken to divide the problem plus time taken to combine the solution. We should also know how to solve this relation so that we can find the approximate time taken to execute this program. Before directly jumping to the merge sort, first we should know how we can merge two already sorted out arrays and sort them in a separately new array. Here, we are given with the two arrays which are filled with the elements which are already sorted out. And our desired output is new array with sorted out elements from the above two arrays. To sort out these arrays, we have to first compare the each element from both of the arrays of respective indexes at a time. If one element is found out to be smaller than the other element, then we will put that smaller element to our new array. Because arrays are in ascending order, this means that the first element of each array will be the smallest element present from both respective arrays. Here, element 1 is the smallest element present from array A and element 2 from array B. So in one comparison, we can find out that which one is smallest of them. Here in this case, element 1 is smallest, so we will assign element 1 to the new array with pointer k pointing initially to the first index. And we will increment the values of pointers of that array, which has been sorted out to the new array. Pointer k will be always incremented by 1, because each time one element would come to this array at a time after being sorted out. Now, our k pointer is pointing to the index 1, I pointer is also pointing to the index 1, and j pointer is pointing to the initially index, which was 0. Now we will compare the element I is pointing and j is pointing to. We can see here that element 2 is the smallest when compared to element 3. So we will move element 2 to the new array. Value of j and k pointers will be incremented by 1. And the value of I pointer will be same as the previous value, no change. And similarly, we can compare and sort out these elements into a new array. Now, there's only one element left, which is 60. And we can see that the elements left in the array B are all smaller than the element 60. So all the elements will be moved to the new array except element 60. We can see that the array B is empty, and the J pointer is pointing to an invalid index. Now, if we try to compare the element 60 with the element of unknown index, this will give rise to a runtime error. So, how can we inform our computer that, from two of these arrays, which one of the arrays is emptied first? We have a solution to this. If we suppose that the size of the array, A and B as X and Y respectively, we can easily check which one of the array is finished first. We will check the values of size of the arrays and respective pointer, pointing to which index at that time when all the comparisons are done. If we have to check that the array B is emptied first or not, we will confirm that is the pointer J is pointing to the same value as the size of the array B. If that is so, we can confirm that our array is emptied. So, the leftover sorted elements of the array will be copied to the new array. For copying the leftover elements of that particular array, we will initialize a for loop, starting from the recent index of that array which is not yet finished, and till the last index of that array. And each time we can assign the leftover elements to the new array one by one. Here, element 60 is left, so we will assign this to the new array. So, if the array A was finished first, this would be the code to copy the leftover elements of array B to the new array, which is vice versa. Here, we also notice that the comparison is not done only once, it is done continuously. Can you guess what would be our next step now? Yes, we are right. We will use the concept of loops. We will repeat this whole procedure until the one of the arrays are not finished. If, out of these two arrays, one array gets finished first, we will stop doing comparisons and will start copying the leftover elements to the new array. For this, we have to initialize a while loop, which will run until the one of array gets finished out. For this, we will check that the size of array A is not yet equal to the index pointer I is pointing to, and the size of the array B is not yet equal to the index which is J is pointing to. If any of these statements gets false, this will indicate that out of two arrays, one of these array has finished out, so there will be no more comparisons performed, meaning that we came out of the loop. After coming out from the loop, we can copy the leftover elements of respective leftover array to the new array. In this way, we can merge two sorted arrays into a newly sorted array. I will suggest you to watch this video again, so that your base can be strong enough to teach this topic better than your professor. In next video, we will see how we can write a pseudocode for merging and sorting with the help of only one array. Till then, keep grinding.